This is Sainath Jamula, acting as a project manager for this week's project summary for Astrotech, and I'm here with my project team. And next, for this week, we are giving a summary of the entire project we have been phased out in the whole 8 weeks. And by using the foundational project management principles and clear scope definition and the stakeholder collaboration, our team successfully designed and prepared to build the Texas Wildlife and Parks research vessel. Through systematic applications of these methodologies, we ensure alignments of objectives, we optimize resources planning, and delivered a robust and executable plan. And for this presentation, the key deliverables are board design, organization structure, bill of materials, operation and budget planning, network diagram, which we'll be discussing briefly in the further slides. Now my friends will be taking over.
Hello, my name is Seung Hong. I was the project manager for week one. This is incorporating trying to figure out the boat design for initially figuring out the overall configuration of our boat, looking at different methods. We had about 4 different parameters: construction, hull material, engine configuration, and operating conditions. And with all 4 of these parameters, we had about 24 different configurations, looking at overall size of the boat, type of material we'd be using, the number of engines, and the cabin coverage. Here, so overall, we're trying to identify, procure, customize a small power boat for marine research, as stated earlier, for the Texas Wildlife Parks and Wildlife. So that we'll look at different factors such as uh, using a specific method for the constrained weighted factor method. On to the next slide. Here are the results of our overall results. We use this formula up at the top where we uh, looked at a constraint from 0 to 1, gave each configuration a weighted score and a factor score to help us determine which one would be the best configuration for our boat overall. So we chose a 36 foot boat. Hull material was aluminum. Number of engines was a twin diesel, and our cabin coverage was a half cabin. Overall, this is what we found was the highest factor score possible, and this is the reason why we chose this specific boat configuration. Moving on.
Hi everyone, my name is Kayla McDonald, and I was the project manager for assignment 2, where we decided what our organizational structure would be. So AstroTech initially started up as a company founded in January 2025 to meet the specific needs of boat construction. Since it's such a niche market, there aren't many companies willing or able to provide a full range of services required to build a boat, and that's where we came in. Our team is made up of experienced business professionals across departments to ensure we deliver quality work from finish to start. So, as a startup, we've implemented a mixed organizational structure to help distribute the workload effectively. And starting out, we currently operated across several key departments such as construction, operations, supply chain, sales, marketing, project lead, electrical, hull and deck. We split our project up to be able to support the needs of different sections. Next slide. So here shows our mixed organization structure, which is what we're using as a startup. In this setup, we've kept it simple and efficient by dividing responsibilities across key functional departments. Um, and on the other side, which is our mixed organization startup, mixed organization structure startup, it's split between construction, supply chain, sales, marketing, finance, um, a project lead, and manufacturing. Where on the matrix, you're able to get a bit more granular and see how each section is broken out. Thanks.
Yeah, good evening everyone, and my name is Rajesh. And in week 3, we discussed about the BOM of our research board, and we know that BOM is nothing but the list of all material components of equipment built in our board. It covers everything from large systems like propulsion, hull, and like to the smaller essential like sanitation systems and navigation equipments. You notice that that BOM is organized into key systems. For example, for proposal system, it is around cost around 43K, and which is Hello and Deck is the most expensive one. It's around 58 125, and other systems like electrical system, freshwater sanitation system, and all are listed here in individual cost. When you all add it up, to total estimation cost of a boat is around 136K. And can you move to next slide? Yeah, now we talk about the BOM and the significance importance of the BOM in our project. First, it enables the comprehensive material planning. It by listing every part material required from cables to motors. It helps to accurate the total cost estimation and budget controls by clearly breakdowning the cost by system and making sure when we stay within budget. Another big advantage of it is like streamlining the procurement process, reducing errors and delaying by giving supplier exact specification and quantity. It also helps us with efficient project scheduling, and moreover it also supports like safety and compliance by making sure all materials meet marine safety standards and regulatory equipments. Lastly, it ensure improved quality control during assemble, because having a clear BOM means it right parts go in the right place. In conclusion, BOM forms the backbone of a project, keeping cost control, material organized, and guaranteeing the final boat meets and operations and safety standards. Thank you.
Yeah, my name is Carrington Moore. I was the project manager for our planning portion. So our initial project planning phase broke down the project into a few different phases. Planning, then construction, which had its own subphases, C-test, and delivery. This is what our original diagram WBS looked like. It had each of those broken down with the subsystems inside of them, and you can see our subsystem assignments out on the left. Next slide, please. So our Gantt chart then came out of our WBS, and it began with an understanding of the needed order of operations and dependency, and expanded out to fill 20 weeks of time. We later discovered a flaw in our planning, as we didn't really account for worker hours, and our starter plan had awkward work weeks a lot, which did help later on with the crashing and leveling that we'll talk about in a couple of slides.
I'm Venkat Seriguntoju. I'm the project manager for project budget planning for fifth week. And in this project, we use bottom-up budgeting approach to estimate costs at the task level, allowing for accurate resource planning. Learning curves were applied to reduce labor hours, overtime, and improve efficiency. Labor costs were broke down by skill level and tracked weekly. Professional is 71K, and skilled is 71K, and unskilled is 57K. And we estimated the fringe at 25% rate, and the total labor cost is 249K. Material procurement was concentrated in week 3 and week 4, covering the 85% of total material, with peak spending in week 4. Next slide. The total project budget was 750K. There's a limitation. We spent only 533K, which staying under the budget at about 29%. And labor is 248K. Materials is 135K. You can see in the pie chart and in the table. The project maintained the cost efficiency while keeping the flexibility for future adjustments. That's it. Next.
Um, for the network diagram, the main goal is to develop a simplified network diagram for a WBS and Gantt chart by using the set of activities rather than individual work packages. And for this one, the sequential work packages with single predecessors and successors has been combined into one set of activities for the network. So this is a graphical representation of project activities and dependencies, and we created it based on the predecessors listed in our Excel file in the previous sheets. For this, we have created two tables. One is a earliest and latest start finish table, which helps us to determine the project timeline, and the other is slack calculation table. And this Slack calculation table plays a major role in identifying critical path activities where Slack is zero, ensuring these activities are monitored closely without any delays expected. Next. So this is our network diagram for the project which are currently undergoing. And for this, you can see the one that's marked in red is our the networks where the slack is zero, which is called the critical path. And by following this structured process, we have achieved several benefits like better scheduling and execution because the tasks were assigned definitive timelines, ensuring a well organized approach. And even by understanding when each task starts and ends, allowed us for efficient allocation of labor, materials, and machinery. And by identifying the critical path, we pinpointed high risk task, which is the one that's mentioned in red, that needed strict monitoring to prevent delays. And the Slack calculations helps us to see which task had scheduling flexibility, allowing for better adjustment to real world conditions. Next.
After that, we started to try to factor hiring and firing into our schedule to see how that would affect our overall budget. We utilized a basic assumption of $4,700 per hire and 1 week of pay for firing or severance, and it ended up increasing our spending by a total of $143,000. As mentioned previously, this cost was more than needed due to inefficient planning of working hours and then unsustainable hiring firing rates ended up emerging from that, which does lead us to want to potentially change our schedule. Next slide, please. Which brings about the option of crashing the network. Crashing didn't actually end up helping like it could have. It led to increased overtime and worse hiring and firing levels due to more awkward weeks of labor than before. Our overall time did end up decreasing by 4 weeks, and our overall spending only increased by about $82,000. And it didn't surpass our budget by very much at all, only about 10,000, which, considering that the budget was 750,000, isn't that large of a gap. Crashing is definitely worth it compared to the original budget, but does come up short when compared to leveling, which I'll pass it off for the next person to talk.
All right, now we've gotten to leveling. So in this slide, we're focusing on resource leveling, and we were able to find some gaps in our schedule where certain team members, specifically on the design team, had uneven workloads across the spread or the duration of our project. You can see on the chart in the middle that the hours were planned very front heavy with some team members being overutilized and others being underutilized in some areas. And this type of imbalance can lead to burnout and inefficient use of time. By redistributing the workload more evenly across the week, as shown in the chart below, we're able to maximize allotted hours, reduce idle time, and improve cost efficiency. This also helped us avoid unnecessary hiring and firing since we're making better use of our current resources. So lastly, in our hiring and firing costs slide, we'll be going over what the results were from leveling out our schedule. So in our project leveling, the leveling extended the schedule slightly to 17 weeks, but it kept our costs down to about $32,000. By comparison, crashing the network or crashing the schedule would reduce the timeline, but just by 1 week, but with much higher costs of roughly $82,000. That's an increase of over $50,000 with very little time saved. So, yeah. Thank you all so much for listening into the AstroTech construction of our boat.